Alright, welcome back to another episode of Akya's classes. Today we'll be exploring a Fibonacci sequence and how the dynamic programming can optimize its computations. So we'll dive into first the advantages, then disadvantages, walk through the steps, pseudocode, and then we'll move on to the practical steps of it or practical implementation of it. So first, let's just take a look at the definition as we always do. So Fibonacci sequence is a series of number where each number is a sum of two preceding ones, starting with 0 and 1. The dynamic programming approach optimizes the calculation by storing intermediate results and avoiding redundant calculations. So basically all you have is a simple process of calculating the Fibonacci. Let's say if I were to calculate the Fibonacci of 3 into 2 into 1, that is the Fibonacci process. That means I'll get an output of 6 if I were to enter 3 as my number, then I'll get 6 as my answer because the Fibonacci of 3 is going to be the 6. If I were to enter 10, the answer will be, I guess, 55 or something. So that's how the Fibonacci sequence actually work. So let's take a look at the advantages. No, let's just take a look at the steps first, then we'll move on to the advantages and disadvantages of it. Alright, so step 1, create an array to store the Fibonacci number. Then you have the step 2 is to initialize the two values, the Fibonacci 0 and the Fibonacci 1 as 1. And then you fill the array by summing the two preceding numbers for each position. And then you return the number at the desired position. That is the simple process. Now let's move on to the advantages and disadvantages. So first, advantages is efficient calculation. So by storing the result of sub-problems, we avoid recalculating the same values, making the algorithm ON in time complexity, which is really great. Then we have simple implementation. It can be implemented iteratively, saving space compared to the recursive approach. Now let's just take a look at the disadvantages of our Fibonacci. So disadvantages are pretty simple: space complexity and not ideal for large numbers. So space complexity, depending on the implementation, dynamic programming might require O into N spaces to store intermediate results. Though it can be optimized, but still it is not an ideal one. Then not ideal for large numbers, as I've said earlier in the space complexity, since the Fibonacci numbers grows exponentially, handling very large values may require special data types or maybe libraries in some cases. So now let's just take a quick look at the pseudocode and then we'll move on to the practical implementation. So the pseudocode is pretty simple. You create a function Fibonacci, then you initialize an array to store the Fibonacci number. Then you set the Fibonacci 0 and Fibonacci 1 as we discussed in this step. Then you create a for loop for each I from 2 to n, then calculate the Fibonacci of I as Fibonacci I minus 1 and Fibonacci I minus 2, and then you return the n. And that's how the game works. So now let's just do that in the practical implementation. It's not going to be a long, it's basically going to be like 1 to maybe 6 or 7 lines of code, I think. Not too much, maybe 8 max to max. So let's just do that and find out how much. So we are on our coding screen. Let's just create a function calling it the Fibonacci. Alright, and then pass on an argument calling it n. Right, now we'll just initialize an array to store the Fibonacci numbers. Now once we have done that, we'll create the base cases, which is going to be the Fibonacci 0 and Fibonacci 1. Once we're done with that, we'll build a Fibonacci sequence from bottom to top. For that, we'll just use a simple range. Right. K n minus 1, and this is going to be I minus 2. And once we're done with that, we'll just simply return the Fibonacci of numbers. And this is where we are done creating the entire algorithm. This is it. That's it. We don't have anything complex in it. It's just that simple. Now we'll just create a result variable in which we are going to use this function Fibonacci. And I'm going to show you how to exactly print that in a way that it looks at least good enough, that it makes sense and looks clean as an output. Fibonacci number is result this. Alright, so once we run this program, we'll be able to see the output. It looks clean and good. The 10th Fibonacci is the 10th Fibonacci number is 55. That's perfect. Alright, so that was all about today's Fibonacci sequence using dynamic programming. So as you can see, this approach makes calculating large Fibonacci numbers efficient and easy to implement. So if you liked the video, give it a thumbs up, and if you didn't like the video, give it a thumbs down. So don't forget to subscribe the channel for more content like this. So we'll be back with some new algorithm tomorrow. Till then, keep watching Akyas classes.